So hey everyone, welcome again to my YouTube channel, and today we are going to solve a new question from our top interview on 50 question series, and the question name is minimum window service string. So let's get to the question. So what we have been given is that we have been given a to a string s and t which are of length m and n respectively. We have to return the minimum window service string. That means we have to find the minimum window in which that we can find the all the character of the given service string, which is s. Now it is given that it may be including duplicates. That means included duplicates are allowed, and if there is no such substring, return the empty string. The test cases will be generated such that the answer is unique. So this is the question. So let's first understand this question and let's find out the algorithm which we can apply. So this is the first example from our question, and from this example let's first understand that what our question is asking for. After that we will also discuss the algorithm to solve this question. So first, our question is simply saying that we have to find the minimum window. So the minimum window is a clear indication that we have to use the sliding window concept, and in that we are going to use two pointers which are going to move in this given s string, and in this s string we are going to find the substrings that consist of all the character of this given t string. So finally, we have to find the minimum length, which is going to consist all these characters. So if you see in this given string, if you start from the beginning, if you take this much of substring, that means from this index to this index, you will get all the characters in our given t string. That means you are getting A, you are getting B, and you are also getting C. Now this is the first, and the length for this string is going to be 6. Now again, if you move your pointer, that means you're starting your pointer I is at this position and your j is at this position. Now for the next window in which you are getting all this string, if you try to find out, so what you will do, you will move your j pointer, sorry I pointer, and you will also move your j pointer. So in this case, now you will get your next in this, that means you are getting b c, and until you get a, you are going to move on. So this is the second string which is going to give us the desired result, but its length is going to be equals to 1 2 3 4 5 6 7 8. So this is greater than our previous one, so this is not a feasible solution for us. Now again, when you move on and when you start from this c, so what you will get, that you will get c b a. So this is going to be less, which is going to be 6 again. So this is similar to our previous one, which is equal length. Now again, when you try to reduce more, that means you again move your I pointer, you will start from this index b, and the next string which you are getting is this string which consists of the all the characters, that means abc. So this is of length 4, and here you can clearly see that the minimum length or minimum window length in which you are getting all the character of this given t string is going to be this one, which is starting from this index and is of length 4. So this is our desired result. So this is the question which is it is asking for. Now let's understand how we can solve this. So the concept is simple. So we have to simply find out the best possible way to do this, because the algorithm is going to be little bit complicated, but it is very easy. So let's start and find the algorithm by which we can solve this problem. So in this step, what we can do is that first we can store this given string t in a map. And how we can do is that we can store this each character with its frequency. So A is stored with frequency 1, B is stored with frequency 1, and C is stored with frequency 1, because all three have a frequency 1. Now why we have done is that we have to find out that until our iteration, does we have found all the characters or not. So that's why we are going to use this, and it is also going to help us to find out that the current position index is required to be found or not. So let's assume you are at the first index. So what you see that your first character is a. So first thing which we will do is that you will first check that if this character is present in your previous map or not, that you have already created. If it's exist, that means this is the one which is required in our which is required in our answer string. So if it is required, first thing you have to do that we have to increase this. That means you have to write a is equals to 1, because it is going to be a map, and if we are going to again store in this a map, and each time you find a character, you increase its frequency. That means if you again find a, you will going to increase its frequency. So you will check if the frequency is less than or equals to your previous frequency which is stored for our given t string. So that means this is the one character which is needed in our required answer. So what we will do, we will increase our count to 1. every time we have to do this. If it satisfy the two conditions, that means the character is found in our previous map, and if its frequency is less than or equals to the frequency present in our previous map which we have created. Now again, when you move to the next index, you will find D. So you will check if it is present or not. You can clearly see it is not present. So we can simply write its frequency equals to 1, and we do not increase our count. Again, when you move to 0, or sorry, O, you can again increase its frequency to 1, and there is no need because it is not present. Now next, this time when you move to B, you will see that B is present with frequency 1. So here what you will do, you will first increase its frequency, and you will compare that if its frequency is less than or equal to the our previous frequency. So here you can clearly see its frequency is 1. So what we have to do is that we have to increase our count to the next. That means our 1 becomes 2, because we have found the second element which we needed. Now again, when you move to E, you will again see the similar condition. That means we will simply store it and no count is increased. Now when you move to C, you again see the similar condition where it is already present and its frequency is less than equals to the current previous one. So what we do, we increase our count, which is going to be now equals to 3. So until this position, what you can see that our count is 3, and you can see that the length for this T string is going to be 3. So we can check that if its length is equals to our count, that means we have found all the elements which we required. So when we found all the elements which we required, what we can do, we can store the string, or we can store the length of this string, because finally what we have to do, we have to find the minimum. So we can store the length, and one thing which is important is that we have to return the string, not the length. So for returning a string, you need two things: first the starting position, and second the length. So we have to store these 2 points. So we have to also store the starting index, which is here 0. So this we will store, and we will compare it in next step. Now what we will do, that if you check that your count is now equal, now again when you move to the else part, that means you write a else part in this condition. And we what we do, as we do in the sliding window, that means we will take a j pointer, and this j pointer is now going to move on to the next indexes. So in this condition, your j pointer is first is going to be at 0th position as usual, and after this what will do, you will increase your j pointer to the next. That means now your j is at d position, and in this what will do, when you are removing this a, that means if you are moving this j pointer, that means you are reducing your size. That means you are moving this a from your string which you have got. So what we have to do, we have to also remove this its frequency. So what we'll do, we will reduce this frequency to 0. That means a is removed, and you again check. And what is going to be the condition is that if its frequency is less than or equal to our required sorry given previous map, so we will again reduce our count. That means now our reduce is going to be 2. So previously what we are doing is that we are increasing the frequency, and we check if its frequency is less or equal, we are increasing our count. Here we decrease our frequency, and we will if check if it is less than or equal, so we will decrease our count. So this is what we are going to do. Now your j is at this position, and your count is at 2, and your j is at d, and your a is 0. Now here you can see clearly that now we can see that clearly that we do not have the all the elements which we required in our string. Now we have to move your I pointer. Your I pointer is currently at this position, which is C. Now you move your I pointer, now it's go to O. Now when your pointer go to O, you will check if it is present or not. So it will be present here. So you will simply increase this, and you will can clearly see that it is not present in our previous map. So there is no increase in the count. Now again when you move to D, so simply what happens, your D count is going to increase. When you move to E, your E count is going to increase. And when you move to B, your B count is going to increase. When you move to A, now when you are going to move at the A, what happens, you can see okay, sorry, we have forgot one thing. So here at B pointer, when you have increased your pointer to 2, so clearly you can see that it is present in our previous map, but its frequency is greater than the previous one, so there is no increase in count. So you can simply also understand why we have not done, because it is duplicate. So that's why it is not going to change our count, because we have already found that B. Now when you are at the A, you will increase your count for A. That means now 0 becomes 1, and now at this time your count is going to be again 3. Now again we are going to repeat the same process. That means your j pointer is now going to again move to the next index, and you are going to delete this D. So you are now, your 2 becomes 1, and you can simply see it is not going to impact our C, and again it is going to move to the next pointer 0, and your 0, oh sorry, O becomes with the frequency 1. Again when it come to B, you can clearly see that the count, or you can say the frequency for the B is 2. That means you can check that if it is greater or not. So if it is greater than your previous value which you required, so you can simply decrease this value, and there is no change in your count. So this is not going to impact, simply because your count, or you can simply say that its count is greater than, it is not greater than or equals to your previous one. If it is greater than equals to and you found it, then only our count is changing, and until and without this condition our count is not going to change. So in this, by this process, what you will do is that your zip now move to this position, that means B. Now next it goes to E. Now again it goes to C. Now when it comes to this C position, what happens is that now you have got all the values. So this is the next which we have already found in our previous example. So this is the next loop which we got, which is of length 2 3 4 5, which is less than the previous one. Now again what you do, you store the first position, which is J for this, and its length also. Now again we move this same step, we follow this same step, and at last what you will got, you get this answer, which is going to be BANC, which is of length 4, and this is our final output. So this is the overall algorithm which we are going to follow. I think you have understood very clearly. So now let's move to the coding part and understand it more better, so how we can code this thing. So now let's start, and let's start by taking the length for both the strings. So we are going to take first ls is equals to s dot length, and simply similarly we can take TL is equals to T dot length. Now you can check one condition easily, that if your TL is greater than your LS, so this is a simple implication that number of characters in T is more than number of in character in S. So in this condition we are never going to find all the characters in S. So you have to simply return a empty string. So you can return empty string. Now what we have to do is that we have to take an unordered map. So we are going to take an unordered map of type char and end. Its name is going to be m. Now we are going to run a for loop int I equals to 0, I less than in tl I plus plus, and what we are going to do is that we are going to store the character and its frequency in this map m. So we can write t m t si ti plus equals to 1. Now similarly what you can do is that you can take another map whose name is going to be, we can take 10. Now there are some variables which we are going to need. Is first is going to be our j pointer, and second is going to be our length. So we are going to take it as, let's take is at answer. It's going to be int max, because we need the minimum. The answer is going to store the minimum. So we are in the start we are going to declare it as a maximum. Next parameter is going to be a start, which is going to be the start index for our answer. So we are going to take it as 0, and the last which we need is going to be count. We are going to take it as also 0. Now we are going to run a for loop and I equals to 0, I equals to 0, I less than our ls, I plus plus, and now we are going to check if our count is less than TL. So this is simply implying that we have not found all the characters present in our T in our current string. So if this is the condition, what we have to do as discussed is that we have to add that value in our temp map. So we are going to do the same first. So we can add temp si plus equals to 1. Now as we have discussed, what we need is that we have to also increase our count, and to increase our count we need to check two conditions. As discussed, we are going to check that two conditions. First is going to be, it should be present in our m map. So for that we can do m dot find si is not equals to m dot end. So this is going to simply satisfy that it is present. So if it is present, and another condition which we need to check is that if our value for it in our temp, that means temp si, is less than equals to msi, In this condition, if its value is less, then only we have to increase our count. Now this is the if condition. So now let's move the else condition. So this if conditions is running until we have increased our count to our count equals to TL. Now in the next part, when we have increased our count, what we have to do, we have to work on our J part, which is at first as 0. So when it is first at 0, what we have to do, we have to first check if it is present or not. So we are going to check the same condition. So condition is going to be same. The only difference is going to be uh, in place of I, we are going to use J, because here we are dealing with J pointer. So if this condition is satisfied, as discussed, we have to decrease our count. And one thing which we need to do again is that we have to decrease its frequency also. So in temp, we have to decrease Sj minus equals to 1. Now we have to increase our j and decrease our I, because we need to make our I at a fixed position. So we are decreasing every time, because in for loop it is increasing automatically. Now one thing which you are going to check is that if this is running, because this is the overall loop which we have studied to do. Now one thing which where we have to store our answers is going to be condition when our count is equals to TL. So if our count is equals to TL, what we have to do is that we have to simply do two things. We have to store our values. So first value which we are going to store is a start. So for storing this start, the condition should be if our answer if our answer is greater than equals to I minus j plus 1. So this I minus j plus 1 is the length of the current string which you have in your hand. So if the current length is less, that means it is a favorable condition, because we need to minimize it. So this is the condition. So we can update our start with j. So we can have point start is equals to j. And another thing which we need to do in every time is that we have to update our and we have to update our answer, which is going to be ns equals to min of ns comma I minus j plus 1. I minus j plus 1. Now, what we have to also understand that this condition is not always going to be come, because there may be a condition where this all character is never going to be found in the given string. So for that, to handle that situation, what we are going to do is that we are going to take a bool value, and it is going to be f equals to true. And if it's come in this if condition, we are going to update it. So we are going to do f equals to false. So it is going to show that at least one time we know our start value and we know our ns value. So finally we have to return. So we are going to check if our f is equals to false, that means this is a favorable condition, and we have to return s dot substring. So we write substr, and what it is the parameter first is going to be a start, is the starting index, and the length of the string from a starting index we need, which is ans. And in else part, when it is true, we have to simply return an empty string. So we return an empty string. So this is the code. Now let's run this code. So we have forgot our semicolon. So let's correct the semicolon somewhere. So here is the error. So let's correct it. Now this is looking nice. No, now let's one thing which we need to improve is that we have to run this until ls plus 1. Now let's run again. So this is accepted. Now let's submit this code. Okay, so this is successfully submitted. So this is the question for today. This is a very interesting and very important question. So thank you all.